5, 9, 20, 24, I think, from the picture I took of my hand. Let's go to 5. Really? 5, y equals -2, so there's... that's not it. I'm looking for it. Give me a second. Hang on, guys. Five. Okay, so that's not it. That was the other days. 5 is -2x minus 9y equals -25. -4x minus 9y equals -23. So when you have two equations and they both of them share a same coefficient, there's not much to do. Now the only thing you have to decide is whether you add or subtract. So so I told you in class, if they're the same, we want to subtract, right? If we subtract, be really careful. It's -2x minus 4x, which becomes -2x plus 4x, so we get 2x positive. -y, 9y minus -9y actually is -9y plus 9y, so that becomes 0, so that goes away. -25 plus 23 is just equals to -2. Divide both sides by 2, x equals -1. Pick either of the equations to find y, so let's just pick the top one, -2x minus 9y equals -25. I know what x is, so I'm going to substitute that with -1. Minus 9y equals -25. This is positive 2. Minus 9y minus 25. Minus 2 on both sides. -9y equals -27. Divide both sides by -9. And negative divided by negative is a positive, and we get y equals positive 3. So I told you that you have, I guess, because like I said, nobody likes to check. But the point is -1, 3. I would check. So check, I would take the point -1 and 3, substituting both equations. So let's take the first equation. It's 2 times -1 minus 9 times 3. And that should give you -25. Let's see if that's true. That's 2 positive minus 27 equals -25. And in equation 1, it worked out nicely. In equation 2, -4x minus 9y equals -23. Let's substitute. So we get -4 times -1 minus 9 times 3 equals -23. This is 4. This becomes -27 equals -23, and you can tell they are the same. So the point -1 and 3 satisfies both equations, right? It's done. So if you were to graph it, I'm just making this up, but that's the point, right? The point on the line, and that point exists on both lines. That's why both equations are true when you substitute -1 and 3. 9, I think, is the next one. 5x plus y equals 9. 10x minus 7y equals -18. It really doesn't matter which one you choose to eliminate, whether the x or the y. I'm going to choose the x because for me that's easier. You want to choose the y, that's fine. So I'll multiply this by 2. If I multiply that by 2, the whole line by 2, I get 10x plus 2y equals 18. So now let me rewrite the bottom equation here. So 2 times 5 is 10, 2 times y is y, and 2 times 9 is 18. So I'm going to work with these two now. The x's have the same coefficient, so I'm going to subtract. When they're the same, you subtract. So 10x minus 10x is 0. 2y minus 7y is, careful here, 9y positive, and then 9 minus -18 becomes 9. Yes, sorry. 18 minus -18 becomes 18 plus 18, which is 36. Divide both sides by 9, and we get our y is 4. So we have we have the y coordinate, we need the x coordinate. So pick any of the equations. Let's just pick the 5x plus y. So 5x plus y equals 9. I'm going to substitute the y was 4, and I get 5x plus 4 equals 9, minus 4, minus 4. 5x equals 5, divide both sides by 5, x equals 1. So here is the point of intersection, and there is a solution to this particular problem. Let's do a check. First equation, 5x plus y equals 9. Let's substitute the point 1 and 4 over here. Make sure it works. So we get 5 times 1 plus 4 equals 9. And we get that 5 plus 4 equals 9. 9 equals 9. Equation 2, we're going to substitute 1 and 4 again. We're going to substitute in 10x minus 7y equals negative 18. 10 times 1 minus 7 times 4 equals negative 18. 10 times 1 is 10. 7 times 4 is 28 equals negative 18, and that's at 0. 10 minus 28 is negative 18, and you can see both sides equal each other. Okay. On the following page, the next question was, I have no idea, is take a look at the picture. Question 20 and 24. So 20, we have 3x minus 2y equals 2. 5x minus 5y equals 10. So in this one, again, if you pick either the x's or y's, pick one first. Doesn't really matter. I'm just going to keep with the x's. So the least common multiple is 15. So I'm going to multiply the top line by 5 and the bottom line by 3. This way my x's equals 15. So let me write that times 5 and the second line times 3. So if I do that, the top line, I get 15x minus 10y equals 10. And the bottom, multiply the whole equation by 3, I get 15x minus 15y equals 30. I can now add or subtract, and in this case, because they're the same, I'm going to subtract 15x minus 15x is 0. Negative 10y minus negative 15y actually becomes negative 10y plus 15y, which is 5y. And 10 minus 30 equals negative 20. Divide both sides by 5, and y equals negative 4. Where you substitute now to find x is up to you. So again, our coordinate right now looks like this. We need to find x. So pick any of the 4. Let me just pick this one over here, right? So I'm going to pick 3x minus 2y equals 2. 3x minus 2 times negative 4 equals 2. 3x plus 8 equals 2. Minus 8 on both sides. And we get 3x equals negative 6, divide by 3 on both sides, and x equals negative 2. So there's the point of intersection. Check. Hopefully some of you are actually doing the check. I'm going to check in equation 1. So again, we have equation 1. We can use this one or the second version. You just use this first version because it's a smaller number. So 3x minus 2y equals 2, and we're going to use the point negative 2, negative 4, make sure that works. So we get 3 times negative 2 minus 2 times negative 4 equals 2. 3 and negative 2 is negative 6. This is going to be positive 8 equals 2, and you can tell that it's the same. Second equation, I'm going to use, let me change colors here, 5x minus 5y equals 10. So if I use the point negative 2 and negative 4, let's see, it's 5 times negative 2. Minus 5 times negative 4, and that should give me positive 10. 5 and negative 2 is negative 10. Negative 5 and negative 4 is positive 20, and we're good. So that point, negative 2 and 4, satisfy the top and the second equation. And we have one more, which should be number 24. I'm not too sure. Yep, it looks like 24. Let me scroll down. 24, we get 3 plus 2x minus y equals 0. 3, negative 3 minus 7y equals 10x. So I'm going to have to make some arrangements here. So let's take a look. Let me see if I can drag this. No, I can't. Let me see if I can drag this to the side a little bit. Let's take the first equation. So the first equation is a mess. So you have 3 plus 2x minus y equals 0. So let me throw the 3 to the other side. So if I do minus 3, I get 2x minus y equals negative 3. So that's what I'm going to work with. So my new equation, so the equation number 1 is being rewritten as 2x minus y equals negative 3. The second one, second equation, equation number 2, let's rewrite that again. So this was number 1. So equation number 2 is given to us as negative 3 minus 7y equals 10x. Let's get rid of the minus 3, so let's do plus 3 on both sides. And if we do that, that goes away. I'm left with negative 7y equals 10x plus 3. And then let's throw the 10x to the left side, right? So we're going to do minus 10x, and that goes away. So I'm left with 3 on the other side. And the left side, I'm going to have negative 10x minus 7y. Negative 10x minus 7y equals 3. Okay, now I can finally see if I want to multiply top line by something and the bottom line by something. You know, I have 2 and negative 10, so I'm going to multiply that top line by 5. If I multiply the top line by 5, I'm actually going to get 10x minus 5y equals negative 15. That's one, and let me rewrite the bottom equation. Negative 10x minus 7y equals 3. So that's what I'm going to work with. Finally, we can add or subtract. In this case, the signs are different, so the signs are different. We're going to add. 10 minus 10 is 10 plus negative 10 is 0. Negative 5 plus negative 7 is negative 12y. And negative 15 plus 3 is negative 12. Divide both sides by negative 12. Y equals positive 1. So my answer, or the point of intersection, is something comma 1. Let's find the x value. To find the x value, you can use any of the equations. We have so many. We have 1, 2, 3, 4, 5, 6, all different versions of the same equation. So pick one. So I'm just going to pick this one right here, equation 1 here. Okay, so I'm going to use 3 plus 2x minus y equals 0, and I'm going to replace the y with 1. So I'm going to get 3 plus 2x minus 1 equals 0. Combine like terms. 3 minus 1 is 2, so I get 2x plus 2 equals 0. Subtract 2 from both sides. I get 2x equals negative 2. Divide both sides by 2. And x equals negative 1. So that's what I think I have. That's my solution. This is where both lines intersect. So to do our check, you can pick this equation right here, or this equation, or this one, or even these two. Yeah. So pick, there's 3 versions of equation 1, 3 versions of equation 2. Sorry, 2 versions of equation 2. It doesn't matter which one you pick. So I'm just going to stick to the original equation. So check. My first equation is 3 plus 2x minus y equals 0. We're going to use the point negative 1 and 1. So let's see if it works. So it's 3 plus 2 times negative 1 minus 1, and that should give me 0. 3 plus 2 times negative 1 is negative 2. Minus 1 equals 0, and that's definitely 0 on the left side, which is 0 on the right side. Equation 2, change colors here. I'm going to use this one. Negative 3 minus 7y equals 10x. And I'm going to use the point negative 1 and 1 to see if it works. So negative 3 minus 7 times 1 equals 10 times negative 1. Negative 3 minus 7, and that combined gives me negative 10. 10 times negative 1 is negative 10. And you see that both sides equal each other. Okay. Yeah, that's it. There are only 4 problems.